Okay, today we just finished yesterday talking about the tides and how we could write equations. We usually use which function for that? Cosine. And if we're going to be able to write equations, we need to know the high tide and the low tide. I'm going to give you a question about that. And I also want to just give you a plain old-fashioned graphing question. So 4 sine of 2 theta minus pi minus 1. And what's different about this than normal? Where? Which part? The inside. And what was special about the inside? You should factor it. Now, I want you to factor that and then graph what you get for the results. I'm going to pause for a second. All right, so I hope you factored it this way. You took out the 2, and what you have left is theta minus, well, obviously something. Well, how do you figure this part out? A mistake answer is pi, because then you're saying 2 times theta, and you're forgetting that you're going to have to do 2 times this. That would mean 2 theta minus 2 pi. So how do you scale it down to be just a pi? If you use pi over 2. That way, when you multiply this times this, you actually get this. 2's will cancel. There we go. Okay. How many of you factored it properly? All right. So then, if we're going to graph this thing, I hope you had graphed classic sine first. And it goes up to a height of 1 and down to a negative 1. And it had 4 important spots, there, and there. And this is 2 pi, and this is pi, and this is pi over 2, and this is 3 pi over 2. And then this 4 first comes along and multiplies our amplitude. So by the way, if I just gave you this equation and I asked what's the amplitude, you should be able to go 4. If I said, what's the B term? You should be able to say 2. What is the C term? That's the shift, and it's pi over 2, and it's directional. If all you said was pi over 2, I'd have to take off something, and the minimum I take off is 5% on a test, because we give you such a generous, 75% an A kind of thing, with the Marzano style. Anyway, bottom line, you would need to make sure you didn't just say pi over 2 is the shift. It's right pi over 2, because there's a difference. If you shift it to the left, it's totally different looking than the right. Okay, so right pi over 2. And lastly, the D term. And that is the whole thing got moved up 1. And how far is 1? Well, it depends on your numbering. So, all right. So the question would be, really, if I'm going to shift this thing 1, do I do that before I multiply by 4? Well, then that begs the question, and what is the right order to do this in? Should the 4 be done before the minus 1? Yeah, the stuff on the outside follows the normal order of things where multiply comes before subtract. So yeah, you should multiply this thing by 4 first and then move it. Why does that matter? Because if I had moved it first and then changed it to a 4, it would look totally different. All right, so I'm going to grab my graph by drawing it again in blue, and now I'm going to grab the graph and move it up 1. Okay, now one more thing, I got to do some stuff on the inside. Now, does it matter? As long as I do both things on, did I just move it the wrong direction? Yeah, I moved it up instead of down, sorry. Okay, I'll move this down. Okay, now, the stuff on the inside, does it matter whether I do the stuff on the inside or the outside first? It really doesn't. I've told you that the inside first is better, but it doesn't really matter. What matters a lot is that if you do stuff on the inside, you got to do it in the right order. And normally, stuff that's in parentheses gets done first, but we're on the inside, so we don't do that first. We should renumber it first. That is either a stretch or it's a shrink. Seems like it's a stretch, so it's a shrink, because everything on the inside is the opposite of what you'd think. So it's a shrink. Do I actually have to shrink my graph and make it finish quicker? Nope. We make it easier for you than that. We say you can just renumber it. Am I going to multiply everything by 2? Nope. Multiply everything by 1/2. 1/2, 1/2, 1/2. And that leaves us with a pi over 4, a pi over 2, a 3 pi over 4, and a pi. Now, I think it's really smart since, you know why? You know why I think this is really smart? Because nobody gets the wave wrong. Okay, when I mark things wrong, 9 out of 10 times it's these numbers right here are messed up. And I would double check that you're counting logically. And if I put a 1 here, it'll help you understand. 1 pi over 4, 2 pi over 4. Is that really pi over 2? 2 pi over 4? It is. 3 pi over 4 and 4 pi over 4 is really pi. Cool. Then I'm confident I'm doing it right. Okay, so count it up to make sure. All right, so get the extra messy stuff out of there. Okay, these are gone. They've been replaced with these. The red one's gone. Yeah, I can take it out of there. There we go. And now I have my final graph. If I was going to go back and check, I would make sure, okay, did I do this? Did I do the 4? Yep. Did I do the 2? Yeah, that was the renumbering down here. Did I shift it right pi over? Oh, I almost forgot that. Do you see what I'm trying to model here? Is go back and make sure you did everything. Because I did all that work and I could have just lost the point right there. And I didn't shift it. So I'm making sure I did everything. I did this, but I didn't do this yet. Okay, so now I should shift it pi over 2. How far is pi over 2? I can tell by my numbering. That's pi over 2. So this is the distance of pi over 2. So then I should shift this thing pi over 2, and it has a minus in there. So it's right pi over 2 there. Now I'm really close to right, but I'm not. Because I told you that you need to have labeling wherever your graph is. So it's not like I should get rid of these labels, even though there's no graph over here anymore, but I need to add some labels over here. All the more reason for me to be making sure that I have counted, and I know how to count this. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. That makes the next mark 5 pi over 4. And the one at the very end, 6 pi over 4, which could reduce to 3 pi over 2. Okay, I bet some of you, maybe it was just out of laziness, but maybe it's just out of not knowing, didn't label these last couple, and that would cost you. Yes? Like I did mention that it could reduce to 3 pi over 2. Now, if that was your only mistake on the whole problem, there's like 17 steps to this thing, I might let it go. But the answer is yes, you're supposed to reduce those. How much I would take off for it is a different matter. Yes?
Would you want us to relabel the y-axis because we have a vertical shift down one, or should we leave it?
You may just leave it the way it is, but the mistake people will make is they think 1 was here because, you know what I mean? They had a mark there, so they think, oh, I'll shift it 1, I'll move it there. They actually would have moved it 4. Okay, because the numbering had to happen first, and I renumbered it first, and then I moved it down 1. So 1 was only 1/4 of the way to here. You know what I mean? So I needed to only move down that far. Yes? Yes, it is absolutely fine to number it further, but I wouldn't have required that. As long as there is numbering on the y-axis, I'm going to be okay. Okay. Any other questions? Then let's do that tide one. Here's a tide scenario. High tide at 8 a.m. measured at 12 feet above sea level. They have sticks in places where they actually record tides that just have numbering on them, so it's not super complicated to do. The low tide is at 4 p.m. It's 6 feet. And you can make an equation from that. I think that's pretty cool. That you can actually make an equation that will predict the next high tide. Now, in the real world, it's much more complicated. In the real world, things do mess this up. Like, for instance, if you're measuring the tide on the edge of a big, long beach that doesn't have any inlets or outlets near it, then tides act totally differently. Then, think about this, if you're in the mouth of a huge bay you get all the water from this huge bay has to flow out into the ocean and then back in past that little inlet. So like if you're on the ocean like this and you're measuring, you got this dock out here and you measure the tide with the stick sitting in the water here. And you measure the tide going from high tide to low tide. It's going to act totally different than if there's this like big bay in here and it all has to come out through this one spot. See what I mean? The water's going to flow a lot more violently through that spot. The height and the depth of the water is going to change more. So anyway, I'm going to show you a website later where you can get actual readings like this. But so anyway, this swing of from 6 feet to 12 feet isn't that much. I had a kid in my other hour who told me about a scary high tide experience. Have any of you been out and had issues with a high tide versus a low tide? Did you? Tell it what happened to you. I don't know your story, but cool. Do you ever miss it? Do you ever miss it? Okay, all right. Especially this time of year, I could totally relate. I've been to California and it is beautiful. Okay, go ahead.
So we went to the beach.
Mm-hmm.
So my sister and I went bodyboarding on the and it was right when we moved out there, so I was like 7 or something.
Mm-hmm.
And I went so fast across the beach because it's so like long, so there's
Ah,
the sound of it.
okay. All right.
And so it came within like 30 seconds. It like pulled my sister like all the way out to the ocean.
Wow. She have a board or something with her to stay afloat? Okay. Still, I know, very scary, but wow. All right. So the other kid's story was I'm not going to tell it as well as she did, but basically, family goes out at low tide to kind of explore, and it is kind of cool. I mean, I have friends who've done this too. Go out and just look at the like crabs and things that are trapped in little pools because the tide has pulled back, and tide pools. Some places have them, some places don't as much. Like if you've been to Fort Myers Beach, you're not going to see that kind of thing very much. But anyway, there's certain places where it's really cool to see what's left over after the tide recedes. Well, anyway, they were out there, and they got caught out there when the tide came back in. And they were trying, I mean, this is sincere, trying to get in as fast as they could. And at the end, they were walking in water that was up to their shoulders as the water had come, they were walking at first with no water, okay? And by the end, they were trying to get in and the water's to their shoulders. They made it back, but they had a little kid with them. Like the only way you do that is to hold the kid up and above, like on your shoulders. So anyway, it was a really scary thing because tide's not something we're used to here, and it can, be pretty scary. Okay, so anyway, I think it's cool that you can model this and make a cosine equation for it. I'm going to give you some time. Give it a shot. Okay, so here's how you have to do this. If I were you, here's the kind of like little picture I would make. What's that supposed to be? It's supposed to be the tides. It's supposed to be what kind of a graph, sine or cosine? Cosine. We always use cosine. And has my cosine been shifted from normal cosine? Do you get that normal cosine has its peak right at 0? So do you get mine has been shifted? Okay. All right. And does that model our data? Well, maybe not be perfect, but it's got high and low tides, right? Okay, so then I would go on my little graph and go, okay, well then what's that high spot? 12 feet. What's this low spot over here, the lowest it goes, coming over from here? What's that? 6 feet. Okay. And then what's the important thing that I didn't tell you, but you can calculate? The middle line. And that middle line goes like this. And what would it be at? Well, you just average these two numbers. In case the numbers are icky, which they will be, we're not going to give you 6 and 12. It's just a little too easy. But this one happens to be 9. But you average them. You add them together, divide by 2. Okay? And now why is that 9 so important? Because that's what it's oscillating back and forth over. And it tells you what the amplitude is. So from here, y equals, and you have to have cosine, and you have to have theta, and then there's obviously stuff around it. There's an amplitude there. There's a b term here. I gave you an equation to figure that one out. And then there's the c term, which is the shift, and then there's the d term, which is another kind of shift. There's a right kind of shift, right or left. We always use a right shift because there always will be a distance to the next high tide. If you just do it that way, it'll always work. There'll always be a distance to the next high tide, unless it happens to be shifted this way enough so that it happens to be a high tide right at time 0. Okay? All right. So, anyway, I think ours was like that about. All right, so now we need to know these. Dice of Destiny. Row 6. Person 2. Tell me how to figure out the number in the front. What's that thing called again? Amplitude. Good. How do we figure that out? Yes, it's from here to here. I like to think of it as how far apart are those two, and then they, in this case, are 3. So there's a 3 there for the amplitude. Raise your hand if you had that one right. Okay, awesome. Then, Dice of Destiny. How do you figure out that B term? Row 3, person 5, 1, 2, 3, 4. That's you in the back. What's that formula that tells us this? Did you think you found it without the formula, which is okay? Okay. See how important the formula is? All right. Better write this one down when she tells you what the formula is. Period equals 2 pi over b. Now, do you think I told you b? Like b is like the 8 or something? It's not that simple. So if I didn't tell you b, I must have told you the period. So how did I tell you the period? By saying how long it was from here to here, from high to low tide. That's not the period, though. Explain what I'm talking about. Row 3, person 2. Why is it not just from here to here?
That's not a full period.
Exactly. That's a half a period. So time between 8 a.m. and 4 p.m. This was 8 a.m. This is 4 p.m. If my math is right, I think that was 8 hours, right? Okay, so then what is the period? 16. Now back to you again. If the period's 16 and she told you this formula, what should I do? And then solve for b. Okay, so then I rearrange that and I get, can you get that? B equals what? Can you finish that one? You working on it? Okay, good. You are correct. 2 pi over 16, also known as pi over 8. Awesome. So then the pi over 8 goes right here. Now I want you to note this. This is always in factored form. Put a parenthesis around that. If you don't have a parenthesis around that, you've missed a little detail there that we've been doing along the way. All right. So now, how far is it shifted to the right? This is row 5. Person 1, that's you. How far is it shifted, this number here, to the right? All right. I'm going to give you a hint. That spot should be here, but it's not. So it's been shifted. So how far has it been shifted? Well, this is time 0. There is a time 0. It's at exactly midnight. So how far is it shifted from here to here? If that's 8 a.m. and that's 0. 8. Okay. So that has been shifted 8. So that is minus 8. Will it always be minus? Yep. Because we're always going to the right of time 0. You can always do it that way. Yes. Yep. It's 8 because it's 8 a.m. Because the time from here, which is 0, to here, which is 8, it's that distance. And that distance is the time, and that time was 8 hours. Okay, so that's an 8. And then last but not least, we need this number. That's how far up it's been shifted. Remember that green line? It told us the amplitude, the green dotted line? it also tells us how far up this thing has been shifted, because normally that green dotted line would be at 0, but now it's at 9, and therefore this is a plus 9. I didn't say we'd always be going up 9. Could the tides actually be at below sea level? Yeah, if you can be above sea level, you can be below sea level. So this could be a shift down. Okay, so there's a good example of writing an equation for a tide. Yes?
Which one will we start at high tide? Instead of starting at,
Didn't I start at high tide this time?
did we?
High was at 8 a.m. and low was at 4 p.m. So we did start at high tide. So I'll just give you a quick, what if we hadn't? What if we had a wave? There's always, again, our wave is always going to be going up and down, and there's always a distance to that first high tide, unless we happen to have started where the high tide was right at 0, which is really rare and unlikely. Because that means the high tide had to happen at midnight, exactly. You know what I mean? Real world, that's not likely. Okay, so then here we have one where we start at a low tide, and then we get a high tide. I think it wouldn't hurt to have one review question like this, so let's just do one more really quick. And yeah, it's a little backwards because it's got the low tide first. That really isn't going to hurt. It's going to all work about the same. This time it's going to be 4, and this is going to be 8 for the high tide. And this is going to happen at 6 a.m. And this is going to happen at 2 p.m. Write an equation. Use cosine. I'll pause while we give that a try. Okay, so here's what you should have done. First of all, you know it's cosine, and you can figure out the amplitude. The line running down the middle is really important. What's exactly between 4 and 8? 6. And therefore, that line tells us not only how far up this thing has been shifted, plus 6. It also tells us from 6 to 8 is the amplitude, or from here down to 4, and that must be 2. And therefore, there's a 2 right there. Raise your hand if you have the beginning and the end of your function right. Good. Now for the hard part. You go into the middle, and in the middle area, this number here is our b term, and there's a formula for that. Period equals 2 pi over b. Do we know the period? Yes, we do, because between the low and the high is a total distance of, let me think, is that 6 hours? Okay, between 6 a.m. and, oh, wait, 8 hours? Dang it. 6, that's 12 is 6. You're right, it's 8 hours. Sorry, that's 8 hours. If that's 8 hours, that is not the period. What's the period then? 16 hours. So 16 equals blah, blah, blah. Switching this in this place gives me b equals 2 pi over 16. Reduces to pi over 8. Raise your hand if you had pi over 8 in there. Almost everybody. And then this one is moved to the right. How far? That far. How far is that far? Well, if this is 0 to that's 2 p.m., that's 14 hours. Minus 14. Do you get this? It's 14 hours, and therefore that's the shift. Okay. How many of you feel like you got that one right? Good. All right. So we haven't graded homework in a while. We're going to grade some right now. I'm going to pause. Okay, so on this first one, there are some points that we're going to look for. First of all, we got to figure out our high and low tides. And the first low tide we come across, and I know it's temperature, but we can think of it like tide. That's the lowest it ever was. And then this is, correct me if I'm wrong, I think that's the highest it ever was. Do you agree? All right. Now, could you look further in the data and find the next one? Sure, you could, but you don't have to. All you need is one low tide and one high tide to make this work. Okay? So you didn't need that. All right, so how are they going to do this problem? They need to, first of all, have cosine. And if they don't have cosine, take off a point. There's your first point out of 10 points that we're going to grade. Okay. Next, they needed the amplitude. The amplitude is what's exactly between the low and the high. So you average 14.1 and 23.9. And help me, what was that number? The amplitude should go here. What does your kid have? 4.9? Heard that a bunch? Yes? All right. 4.9. That's averaging 4.9. That can't be. Oh, yeah, that's not average. Okay. The average number of between these two is the midline, and that goes at the end. I was saying something wrong here, but 4.9 is the amplitude. Good. That's 1 point. They have the amplitude of 4.9. We're good. The next one is this number at the end, and that's the midline between these two. An average of 14 and 23 should be about like 20, well, I don't know. What do you tell me? 17, 18? What? 17 point? 19 point what? 19 even? Oh, nice. Okay. So then this is, the whole thing is positive, so we're going to use plus 19. Next thing is the, how is that possible? What's between 14 and 23? 19 is. I know, they can get confusing. I got confused just a second ago, so don't feel bad. All right, so next, I'm going to figure out the b term. So we do period equals 2 pi over b. By the way, if I don't know how to say this, the 19, that was worth 1 point. The period is 2 pi over b, and the period is double this distance, because that was just from a low to a high. And you always double that to get all the way back to the next high tide or the next low tide. And so that distance doubled. Can you guys tell me what was that number for the period? Nobody knows? How about this? I know your kid has solved it for b, and there's a lot of smart kids out there. What did it come out to? 2 pi over something? Pi over 12? Raise your hand if your kid had a pi over 12. All right, there we go. Thank you. So we have a pi over 12, and that's right there. Pi over 12, and that's worth a point. And the next one is the shift to the right. From 0, the first low tide was here. This is important. Now, a lot of kids are going to mess this up. The first low tide was here, but that was the low tide. Remember, it's the top of the cosine graph that we want to go to. It's the first high tide. Over there is where they should have done. It should have been 18. And that should be a minus 18 right here. A lot of kids are going to have a 14.1 there. They lose the 1 point. Yes? Okay, everything sounds good except this number was messed up. So they're at 1 point off so far. And then, did they have the plus 19 at the end? Good. They only have lost 1 point in that whole thing then. Okay, yes? I think a lot of kids are going to mess up where those parentheses are this time. You better not on the test. I'm not going to mark it wrong this time. Okay? But for future reference, that's the stuff that's in the parentheses. This is a number that's factored out in front. Okay, just know that for the test. All right, so far we graded 1 point for just using cosine, 1 point, that's our second point, third point, fourth point, 5 points on that one problem. Now we'll do a few points on the next problem. We're not giving them another point for using the right function. They better know that it's cosine. Then the low and the high here again. Help me out. I think we have a 4 here. And then I think a 10. Would those be two that kids might have used? And I get there's a 4.1 here, and there's a 9.8 there. Yeah, the real world kind of sucks. It's not perfectly exactly the same high tide every time in these bays. Sometimes it's a little higher high tide or a little lower low tide. So I get the kid might have used 4 and 10, or they could have used 10 and 4.1. So these numbers can be off just a smidge, and I don't want you to mark them wrong because the average of 4 and 10 is 6. But, no, wait a minute, 7, sorry. It's 7, but if you average these two, it's going to be like, 6.9 or something. So, all right. So the midline here, the line that runs between the low and the high would be right between 10 and 4, with averaging them, adding together is 14, so that's 7. Midline is 7. There should be a plus 7 at the end. That's for our next 1 point. And again, if it's off a teeny bit because it's 6.9 or something, that's fine, because they might have used a different low tide or a different high tide. All right, the next part is the amplitude. If you're right in that middle zone at 7 and you go up to 10, that has a swing of 3. The amplitude then is 3. Another way you can do that is take this and find the difference, but then cut it in half, because that's the difference from the lowest to the highest And that's not really how you do amplitude, so you got to cut it in half. Either way, that's a 3. That's the last point we're going to check. And then the last few points, we have only graded 7 points. The last 3 points are, did they do the other problem? If they didn't do the other problem, take off 2 out of those 3 points. If there's anything missing on this one, you can, like, of the stuff remaining, you could take off 1 there. Yes, make it fast. How many things do you see on the board? There you go. All right. So we have a total of 7 points got graded, plus the extra 3 are did they finish. That gives them a total of 10 points that they could have gotten on this assignment. And again, I put CB in your name next to it. At the end there, as long as they finish, they got 3 free points. So, you know, it's a pretty generous grading scale. Any questions? All right, then. How many of you just graded a paper that was an 8, a 9, or a 10? Excellent. Go back to your spots. All right, so for homework for tonight, you're assigned this one. And remember, I'm going to try to get 2 homework assignments in per week from here on out. I won't make that goal, but I'm going to shoot for it. So we may grade this one tomorrow. So anyway, that right there, there is an answer key that has this one on it. I know you may have looked for the answer key for the other one, and if you didn't look hard enough, you might not have found it. It was there in one of the documents, but it was not easy to find. There's a nice write-up of this one. So again, if you have trouble, there's a key. But do you get this is not exactly a tide? What is it? Ferris wheel. Doesn't the Ferris wheel have a highest moment when you're on the Ferris wheel? Isn't there a high spot? Wouldn't that high spot happen at a certain time? You know what I'm saying? And then same thing, it has a lowest spot, the moment that you reach the lowest spot on the Ferris wheel, and that would have a time. So it's basically the same thing. You have a low spot, you have a high spot, you have the time when you hit the low, time when you hit the high. And the period of it would be how long it takes to go all the way around once. You know what I mean? So if all you have is the time it took to get halfway, like the time it took to get from here to here, you wouldn't want to use that as its period because that's only half of it, right? So it's very, very similar to a tide question. All right? Well, you need to know a formula in it. Somebody in here didn't know the formula. I bet there was more than one. I just knew about one. What is that formula again? Period equals 2 pi over b. All right. And that formula would also be handy if we gave you an equation like this. 2 theta minus pi over 2 minus 7. And then I said, what is the period of this? I'm going to write this part more clearly because that was a critical part. What is the period of this? Well, since cosines got a period of 2 pi, you could say period is 2 pi over b. Normally I give you the period. This time, what did I give you? The b. And so do you get from this, I could look at it, figure out, oh, the b is 2. And so then what's the period of this thing? 2 pi over 2, which simplifies to pi. And some of you might be like, but you told us the cosine always has a period of 2 pi. It starts with a period of 2 pi, but we changed it when we put that in, didn't we? Okay, so I could give you an equation and say, hey, what was the amplitude? And hopefully you'd say, it was 3. I could say, what was the horizontal shift? And you could say, right, pi over 2. I could say, how far did it move up? And you'd say, it didn't. It moved down 7. And I could say, what was its period? And again, this number could help you figure out what the period was. But what if this had been tangent? Dun, dun, dun. Tangent doesn't have a period of 2 pi, does it? What does tangent have a period of? Pi. So you'd even have to adjust your formula and be smart enough to go, okay, so it's not 2 pi over b because that's for sine and cosine. Tangent, the formula would be what? Period is pi over b, because the normal period's pi, and it's being adjusted by b. All right. There, you know everything. But I don't think you're ready for the test tomorrow, for sure. Okay, so, all right, now, test on Thursday. Okay, so tomorrow, review day, test Thursday. All right, for tonight, I recommend you do this London Eye question, because it'll help you start thinking, okay, they don't always have to be a tide that's going up and down. It could be something else. You could also be going back and forth instead of up and down. Could it be I'm running back and forth from that wall to this wall, and I'm at my furthest west when I'm over here? No, actually, which way is west? It's that way. I'm going to say north then. I'm at my furthest north when I'm at that wall, okay? And I'm at furthest south when I'm at that wall. And if I go back and forth, do you get it? A period would be like how long it takes me to go back and forth. You know what I mean? So you have to be able to adjust these in your head to, okay, it isn't always tide, but it's always the high spot and the low spot. All right. Okay, so anyway, your homework for tonight is not just the London Eye question. There's one more document you will find in the Schoology assignment, and it looks like this. Chapter 14, review problems. Open that up, and I'm going to give you a couple of those that I think would help prepare you for this test. Chapter 14, review problems. This very first one, number 1, would be a good one. Why do you think they have time being between 0 and 24? Does that make sense to you? That's limiting it to 1 day, okay? And they have a picture here, and they just, I like it because it's giving you the same kind of a problem except with a different setup. It's like, oh, now I've got a picture, and now I got to figure out how to deal with that. All right? And number 3. You think I'm picking these just randomly? No, I'm using strategery. One of the best words ever. Problem 3. I didn't get one. Okay, so the London Eye question plus problem 1 and problem 3. Now, if you want extra practice, there's a ton here you could do for extra practice. We don't normally give you like extra practice problems, and there is a key for these. So, hey, that's a good thing. Anyway, your assignment for tonight, London Eye plus number 1 plus number 3. All right, that's all I got for you for today.